If you have any questions, there's 5 minutes of Q&A at the end. Definitely ask questions. There's also a break afterwards. Come up and talk to me. Really excited to talk about web components because I love them. I work at a company called Comcast. You may or may not have heard of it. They're a cable and internet provider here in the United States. They also own NBC Universal, which has the new Jurassic World movie coming out next week. So go see that. Little promo push there. Also the Fast and the Furious. That's like a big international movie. I'm married. I've been at Comcast for 10 years, so I have a really long-term relationship with them. Been doing front-end development for 16 years. It's very odd as a front-end developer doing the same thing for a long time because new frameworks come out every week. I have an amazing son and daughter who are just adorable and take up a lot of my time. They're a little bit bigger now because this is probably 6 months ago. So Josie's walking and grabs everything, and she is just, but she's so cute. She is the apple of my eye. And I'm from Philadelphia, so it's about 2.5-hour train ride from here to there. Work at that's the Comcast Center. This building on the right is the new Technology and Product Center. That's going to be opening in, I don't know, they said 3 months ago it was opening. So it'll probably be opening in about 3 months. All the engineers will be moving over to that building. Nice open floor space. Very excited about that. And so at Comcast, we work on a lot of different properties. This is the My Xfinity portal. Gets about 1 million unique visitors a day. It's written Ruby on Rails, just plain HTML, uses some jQuery. Next, we have My Account, which allows customers to manage their account, pay their bill, view their bill, see whatever their users are on their account. This is written in Angular. We have Xfinity Home. This is all web components written with Google Polymer. This was in production probably about 3 or 4 years ago. So we started using Google Polymer when it was in beta 0.35, and we launched a production site. This is a home security site, so this is actually my house. We have cameras. I can control all the lights in my house in case my wife is not listening to her phone. I turn all the lights on to get her attention. You can change thermostats. You can lock your doors. All kinds of fun stuff for home automation. Our latest website that we released is Xfinity XFi. This allows customers to manage their gateway. The biggest thing is if you've seen the commercial, to get all the kids to the table, you pause internet on all their devices, and you can shut off their internet for an hour or two and tell them, come to dinner. That's the big thing. This is a single-page app written with Google Polymer as well. So everything you see here is a web component with the Shadow DOM. And last but not least, of course, is the X1 platform. So if you have TV service here with Comcast, you have Xfinity TV. This is the X1. If you visit the website, that is also written with Google Polymer and web components. So let's get started. I want to talk about my coding journey. I've been programming, like I said, for a long time. And hopefully a lot of folks here can relate. When you first start programming, you're at the bottom of the programming foo. You really know very little, and you start learning syntax, and you learn how to write JavaScript. I love writing JavaScript. And you gain a lot of knowledge over time because everything is new to you. You grow. And for me, I reached this plateau level where I wasn't growing that much. And usually what happens is you're stuck on one project, or you're stuck on one web page, and you're just doing Angular for the last 2 years or whatever, and you're not learning anything new. And so this becomes a big problem. For me, this was Xfinity TV back in the day, so this was a very simple website, simple in today's comparison, where you would click on a thumbnail, and then it would take you to a new page. And everything would go back to the server, new page would generate, JavaScript would rerun from scratch. You didn't have to worry about all this complexity. And fast forward to 2017, where we have XFi, which is a single-page app, progressive web app, all kinds of magic stuff happening, static under the hood, makes CORS requests to an API. But really, the complexity has grown dramatically over the last couple years as web developers. And the amount of choices that we have are just insane. And really, some of the biggest things that I struggle with is which way to go, which framework should I use, which package should I use, and it's really a struggle. My son was really adorable here. He would say I would always say, which way should I go, and he would go that way, and he would just point in random directions, and that's kind of what it is to be a front-end developer today. It's that package looks good, or it has the most stars, or somebody's downloading it, and really it's hard having so many choices. Choices is really tough. Figuring out what to do and which place to go and what framework to use. But at the same time, that's kind of why we love frameworks, because once you pick one of the frameworks, and there's really like 5 or 6 most popular ones, it sets you down a path so that as long as you take their best practices, you follow their documentation, you'll be on this path, you'll get to the end, and you'll have an application that works, right? And you'll have a beautiful scene at the end. It's great. But whatever you do, like once you choose Angular and you try to do something that the documentation doesn't cover, oh my goodness, do not leave the path. It is really dangerous. There are bears. So stay on the path and you'll be okay. But the problem becomes for front-end developers is you learn frameworks and you don't really learn the DOM. You don't understand how the browser is doing stuff. You don't understand how to build stuff from scratch. As Andrew Ray points out in this quote, which I'm not going to read because hopefully everybody read it. But it's not all bad, right? So how many people here use React? It's probably like the most popular. Okay. It was basically everybody, or almost everybody. A lot of these frameworks and libraries actually are using the best practices under the hood. And the reason why React is so popular is because it's all about building reusable components. I think components is like the word of the day, so you're going to hear that like 1,000 times today. In fact, with React, the only thing you do is build components. Since they're so encapsulated, components make code reuse, testing, and separation of concerns easy. And this is a really, really important concept in computer science. You might hear a lot of these words: encapsulation, composition, separation of concerns, functional decomposition. And they're basically trying to tell you the same thing, which is decouple all the things. Break things up into smaller pieces. And I did some Googling on this. There's actually like some PhD folks who wrote some papers, and they have this white paper. And they say decoupling is a fundamental computer science because when you decouple things, the dependencies required by their interactions do not result in coupling, since coupling inhibits change. How many times do you try to change code in one place and like somebody else was using that and then you broke it in some other place and you're like, why? That's coupling. Don't couple. Decouple things. And the reason you want to do this is because simplicity matters. Rich Hickey, who created the Clojure language, this guy is really smart. He has this awesome talk, Simplicity Matters. The one thing that you could do is definitely watch this, not today, after today, but check this video out. It is great. I'm going to reference a bunch of quotes from this video. But Rich Hickey, during this video, he talks about an application, and you start off from scratch, and you're building something, and it's going so well, and you're adding new features, and you're getting so much done, and the months go by, and a year goes by, and then the product team comes to you, and they say, hey, can you add this additional feature? And you get together with your team, and you realize that your application grew up to be this giant elephant, and you have to figure out, okay, how do we add this new feature? And it's like making an elephant move. And it's really complicated. And really what Rich Hickey says is, he says, good design is about taking things apart. It's about breaking things down into small pieces. It's about breaking things down into components. Yay, buzzword of the day. And why you want to do this is because components are really easy to build stuff from. That's the benefit. If you build your application the correct way, where everything's decoupled, you can keep adding more pieces on top. You can pull it apart. You can swap out a Lego brick with another Lego brick. Lego bricks are really good for like showing this visually. So love Legos, and my son had a lot of them. And this notion of components are everywhere. Every framework that you choose today, hopefully every framework, has some notion of components, as Rob pointed out during the keynote. And you're probably wondering, how is Google Polymer different from any of these other ones, which, spoiler alert, Rob already kind of touched on that, but we're going to go into it in a bit. Again, Rich Hickey says we can be creating the exact same programs out of significantly simpler components. Every one of these libraries are building components slightly differently, or have to write the code to do it. And the reason why we need this simplicity, why we need to be writing less code, is because today we are not focused on desktop browsers, we are focused on mobile. How many people here have a mobile phone? All right. 100% of people have a mobile phone. Everybody knows about Alex Russell. I love this guy. He's like the angriest dude when it comes to mobile. So this is a great talk, Adapting to the Mobile Web, Future, Present, where he goes into the problems and limitations about cell phones. And the biggest one is battery, right? Like you'll be advertised that your phone has an A11 Bionic processor that runs at 2 gigahertz. And yeah, the iOS or Apple phone is really, really incredibly fast. But the majority of users in the world do not have an iPhone X or whatever the latest iPhone is. I have an Android. I go with Android. And even if you have 8 cores in it, the phone is not going to run 8 cores all the time because your battery would just plummet and your phone would be useless in about 30 minutes. So it's really slow. And so we got to figure out how do we get really great performance on these mobile phones. And the amount of JavaScript that you're sending down to the phone directly impacts how long it takes for your site to load. And hopefully everyone has heard of these quotes that Google has released, which is 53% of users abandon a site that takes longer than 3 seconds to load on their mobile phone. I'm on the train all the time. Hopefully you can relate. And I'm loading up a website, and I'm like, da-da-da, da-da-da. And then I just go do something else. Because either 4G has gotten really slow, or the site is loading like 500 kilobytes of JavaScript, and my phone is just like, what the heck? But it's just really slow, and I'm not going to wait for it. I'm going to go somewhere else. And that's why AMP pages are really fast and really powerful, because they don't do any JavaScript, and they're really lightweight. The corollary to this is that mobile pages that are 1 second faster experience up to 27% increase in conversion rate. By making your site faster, your site makes more money. That's what that means. So when your product folks says, hey, I want to add this feature, and it's going to cost like a half a second in load time, you say, will that generate more money than you're going to lose from performance? Like that's basically what you could ask. So in order to make mobile pages faster, that's where the Google Polymer project came in. And I really want to emphasize it's the Google Polymer project. They create the Google Polymer library, which we'll talk about in a minute. But their motto, as Rob pointed out, was to use the platform. You might see this hashtag all the time. And the great part about the Polymer team is they actually work with the Chrome team. How many people use Chrome? A lot of people, not many people. Firefox? Firefox is pretty awesome. Safari? So it's always good to do like a random sampling of what web browser you have. Yeah, so they work with the Chrome team, and they can directly influence the APIs that are available in Google Chrome. So today, a lot of developers probably have a code base that looks like this. Lego blocks for the win. Great graphic design. But imagine you have your framework, and then you put all your code on top, which is your application stack. But what if the framework was built into the browser? What if you could send down half as much JavaScript as you do today, and your framework still worked? And this is what Alex Russell talks about in Web Components Just in the Nick of Time. He talks about the history of web components and doing very similar to what Rob did, which is like going and talking to all the framework authors, figuring out what the best practices were. And that's where they came up with the idea of the web component spec. And as Rob pointed out, web components are actually 4 different independent specs. We kind of say web components. I like to say it's kind of like Voltron or the Power Rangers, where individually they're pretty cool, but together they form this powerful thing that you can do lots of magic with. So we're going to go through each one of these. The first one, which is my favorite, as Rob's favorite, as he said upstairs, is custom elements. And you already saw this. There's like lifecycle hooks. These are built into the spec. So you actually have to call it connected callback, disconnected callback, attribute change callback, because engineers, they like really long words for things. And so what you do is you write your class definition. You call custom elements.define, which is a built-in native browser API. You can pass whatever tag name you want. So it doesn't have to be the same name as the class. And then whenever the browser sees hi message, it will instantiate your class, run the code, and do exactly what Rob showed upstairs, which is print out hi message. I should have changed this to hello world then. Then it would have been like the exact same slides. The template tag, this one is another spec that is very, very powerful. You can put markup inside of the template tag. This is a new new DOM node, and anything that you put in there will do absolutely nothing. It's great. You can put images in there with sources. The browser will see it. It will parse it, but it will actually not download the images. You can put script tags in there. It will not execute the script tags. And you're probably wondering, like, well, what the heck is this good for? I'm glad you asked. Thank you for asking. No questions until the end. But the reason for this is a lot of JavaScript you use to create markup. So you'll make an API call. You'll get an array back of objects, and you want to print that on the DOM. The browser will parse the markup once. So you can clone the markup in there multiple times and inject it in the page. And it's basically a performance increase, because the browser will not have to create DOM nodes every single time you clone this and put markup into the page. You probably will never have to use this. Their frameworks will take advantage of this. You don't have to. The next one is HTML imports, which Rob pointed out is dead. They're going to use ES6 modules instead. HTML imports were really great because you could actually include HTML markup inside of an HTML page. So this HTML import could contain HTML, CSS, and JavaScript all in one file. Wow! And you didn't have to write your CSS and HTML as JavaScript and make it a big string. So it was really great. Unfortunately, it's hard to get consensus. So lastly is the shadow DOM. Shadow DOM, again, it's separate spec. You can create any element. You can say attach shadow. You have to pass mode open. There's a mode closed. I'm not going to go into that. Mode open just makes it so that you can actually put stuff in there. And then you can put style and markup inside of the shadow DOM. And that creates a boundary so that any CSS that you put inside of the shadow DOM will not affect the rest of the page. That's how you take a component, you drop it in another page, and you don't have to worry about your CSS styles conflicting. That's the benefit of it. Browser support, this is a little bit out of date because Firefox is actually going to be shipping this in Firefox 60 or 61, which should be coming out in a week or two. Safari has it, Chrome has it, Edge, again, is considering it. They're the best. This is the platform status page that Rob was talking about. This is a little bit old, too, because it's up to like 11,000 votes. And the Edge team has said that they're going to have a blog article about this about 2 weeks about what their future expectation of whether they're going to be implementing this, which they will. It'll probably be like a year from now. There's polyfills, though. But yes, it is a high priority roadmap. Every other browser has it. And the great part about using these APIs that are built in the browser is compiled C code is a lot faster than interpreted JavaScript. So it's close to the metal. It will run faster than a framework will run, or JavaScript trying to do this. And that was the cool thing that Rob showed, is like all the frameworks could have custom element wrappers inside of the Angular code. So they'll still do like DOM markup manipulation, but this can do your custom element instantiation. And the great part is, for everybody who has a mobile phone, you probably have an Android or iOS phone, and 100% of them have these new APIs built in. So you can take advantage of Shadow DOM, custom elements, and you don't have to polyfill it at all. And by the way, the polyfill for custom elements is about 2 kilobytes. The polyfill for Shadow DOM, I think it's about 20 kilobytes. Shadow DOM is really complicated to polyfill, which is why I don't recommend that you use Shadow DOM unless you have to. That's my little segue there. And so I've talked about web components. I've talked about Google Polymer. Web components is those specs. What is Google Polymer? Google Polymer project created the Google Polymer library. Google Polymer library is basically exactly what jQuery is. It's a little bit of sugar on top of the native DOM, which makes it easier for you to write web components. Just to give you a quick look, Polymer has actually gone very much to keeping the API exactly the same as the browser API. So if you were to write a custom element with just JavaScript, it would look like this, where you use connected callback. Polymer, you would extend the Polymer element. You call it ready. Like ready is so much simpler than connected callback as far as a name. But everything looks almost identical. And if you were doing HTML markup, they have a template literal, this is called. So rather than just using a template string, it's a template literal. Everybody knows what a template literal is? Basically, HTML is a function. So someone created a global function called HTML, and this will get passed into that function, and then you can manipulate the string and do all kinds of magic with it. So that's how they are doing rendering. The other great thing that Polymer offers is data binding, which is the ability for custom elements to talk to other custom elements on the page. So you can have this custom element, which will have these props of data store variable, and it could pass it to another custom element. And they have two-way data binding. So if you see square brackets, it means one way. I'm only going to receive that value. And if it's squiggly brackets, it means two-way. It means it can produce the value and also receive the value. And there are lots of libraries available for creating web components. You don't have to use Google Polymer. Rob pointed out a bunch. There's Nutmeg too, which is like a friend wrote that. So I'm throwing it out there. But yeah, if you want to write web components, there's lots of frameworks for you to get started. They're very lightweight, so they add a couple kilobytes onto the size of your thing, onto the size of your web components. And if you're a person who really likes vanilla web components, doesn't like to use any frameworks, you can check out the Elix project. They have a bunch of mix-ins so that you can just do custom element.extends, one of their mix-ins, and get a lot of boilerplate that you would have to write by yourself anyway. And so I get this question a lot. What framework should I choose? I'm sure this was kind of like which way do I go in the beginning. And so Rich Hickey, going back to his talk, he says programmers know the benefits of everything and the trade-offs of nothing. Everyone's like, yeah, let me use this cool, gigantic framework. And we do this a lot at Comcast, too. I hate to point this out. This is the Xfinity Mobile website. It is a promo site to sell mobile phones. Oh, by the way, we do have phone service. It's a great thing for you to check out if you are a Comcast customer. It could save you some money and sales pitch. But this site is written in Angular. It's a sales promo demo site. It does not need a gigantic framework. And the problem with the gigantic framework is if you load this on your mobile phone, which, again, it's for selling mobile phones, it takes over 15 seconds to render. That sucks. So what you need to consider when you're choosing a framework is what is your target audience. If your target audience is mobile, do not go with Angular, at least Angular.js. Angular 6 is much better. The Angular Ivy is amazing. It's like he did the hello world in 2-point-something kilobytes. That was awesome. I'm really excited for that. But this is the current framework size. Even React is about 35 kilobytes. There's Hacker News PWA site, which actually has Hacker News built in multiple frameworks, and you can see how long it takes for them to start up. You can check that out. Vue.js is pretty good. I don't have Preact on here. Preact is 3 kilobytes. I really like Preact. I'm like all about small size because the less JavaScript code that you send down, the faster that it is. So if you're dealing with mobile, you really want a small framework size. You want to send less code down to the browser. And as Rob pointed out, you can use web components and custom elements and components written with Polymer or Angular element, or there's actually Vue.js also has a Vue web component output in their new CLI. You can write web components, and they'll work in any framework that you choose because the Web Components API is built on the platform. It's the same way that you can use AJAX or XML HTTP request or fetch because the browser is doing that work for you. It's not the framework. So it works across all of them. If you want to figure out how to get custom elements going across all the different frameworks, there's a great talk by Rob Dotson. He actually even has a website called customelementseverywhere.com. He actually has custom elements working in every framework, and there's open bugs across all the frameworks to figure out like different gotchas that can and cannot happen. So you can check out their website if you're interested in doing vanilla components across different frameworks. And that concept is really important, especially at larger companies like Comcast, where, as I showed in the beginning, we have every single framework imaginable running, literally every framework. So we are using Vue.js to Polymer, Preact, React. We use all of them because we're huge. The other thing, we also use vanilla components. So the toolbar that exists across all of our sites is a custom element. I wrote it. It's great. So yes, I've written a custom element. It's in production. This gets downloaded a few million times a day. And the great part about it is you just include a script tag. The script tag is a little different now, so we actually test for whether custom elements exist in the browser. We have an ES5 version and one for browsers that do have custom elements because it's really hard to do browser detection behind the scenes. But the benefit is you load the script for the custom element, and then on the page there's now this XC header custom element tag that any one of the third parties can throw in. They set different attributes on there which customize the look of the header. And additionally, that same script tag has XCFooter, which is another component, which is this footer that exists down the bottom. And this is just using custom elements. It's not using shadow DOM. So we did all the CSS with BEM syntax. So it's XC header dash whatever. And that way we don't have too many style conflicts. There are still some third-party sites that include this, and they do wildcard content box, border box. And I'm like, no, you just don't do that. Don't do that. If you're interested in checking out the Polaris header, we did open source it as a reference so other people can see how to create a custom element from scratch. So you can go to Comcast/Polaris. And now we're into the second half. Is like, how would you write an application with just web components? Like not even really using a framework, which I really love that Rob had a really great intro to this kind of talk. And like I said, XFi is written completely with web components and Google Polymer. And Google Polymer is not necessarily a framework. They call themselves a library. The way you know that it's a library or framework is because you go to their website and they'll say it's a framework or it's a library. That's the only way you really know. So first, our server architecture for our site. XFi is what's called a jam stack. How many people have heard this term? I think it's growing in popularity. OK, just a couple. So now after this, everyone knows what this means. Jamstack is just JavaScript, APIs, and markup. It means our site is completely static. We generate it during build time. We put it up on an Nginx server, and it serves JavaScript. That's it, and an index page. And then all the calls for the data is actually hitting a separate API that's hosted on another domain, SIORC, and that all the calls happen through cross-origin request sharing. And the great part about the Jamstack is we have no load testing. It's fronted by a CDN. You can hit it as many times as you want. There's no downtime. We don't get phone calls because nothing's breaking on our server. We have no middleware dev server. We actually just start up an HTTP server and server content. And we can deploy in less than 5 minutes. So you want to make a change? Cool. We can make changes pretty darn quick. So I really like the Jamstack architecture. It's fast. There's no middleware. It's great. And the other benefit of that is we separated out our front-end markup from our API. So we've decoupled the two so that front-end never goes down. API can have issues. The API team gets called, not us. I get to sleep. That's really all that I'm worried about. So let's now, after server architecture, let's talk about building an app. And so we follow the purple pattern, which I have to read this because I never remember exactly what this means. It stands for push critical resources, render the initial route, pre-cache the remaining routes, and then lazy load everything else that you need. And so this relates to the app shell architecture, which basically is you have your index page, you load your main component. The main component generates the initial view, everything that the user is seeing. Then you're lazy loading in the additional pages in your single page app. They're separate bundles that get downloaded. And then you download additional stuff before the user interacts with it. And so this is the recommended thing that the Polymer team threw out. And I'm like, this is good, but we can do better. We can do better. We have to do better. And the problem with a lot of apps today, regardless of what framework you have, is you usually have this app component at the top level. And then inside of your app component, you're doing authentication, you're making the initial data calls, and then you're showing your initial pages. And the problem with this is, in the very beginning of your site loading, this is all JavaScript being processed. This is your framework booting up. And that's bad, right? We used to believe, we had this thing, everything should be a web component, right? No, do not do that. Not everything should not be a web component. Everything does not have to be a component. Remember that these custom element specs are another tool in the toolbox. You have to use them wisely. You can use custom elements. You can use shadow DOM. You can use template. They're all independent. You have to know when to use them. And so for us, on our website, our critical path to getting something for the user is we need to authenticate really quickly. Then we need to make API calls. Getting information about your Wi-Fi network takes a long time because sometimes we have to go all the way down to your house to be like, what's on their network? So that could take some time. And then we want to load the view. So we want to get these other things started first. So what we did is we break out our auth and our data function calls as JavaScript. And that happens before we even load framework. That way we don't have to wait for Angular to start up or React to start up. we can start making those calls as soon as the browser hits that script tag, and then we load in our views afterwards. And this is a much better thing, because now we can get all that started, then we load our app, and then our app starts loading the additional pages that's on our site. A lot of people wonder, can you use Redux with Polymer and web components? Yes, Redux is a library. It's a state store. You can use that with any framework. And it's great. Unidirectional data flow, really like it. This was one of the things that I've kind of grown accustomed to using. And the reason for it is it decouples your state from your UI. All your business logic can be held in JavaScript. Your UI is just a view, which is receiving an object and displays. Unidirectional data flow, everything's coming from the top down, so all your views will update. Loadable state, great community tools with Redux. It's a great library. But to visualize this, we have our JavaScript store at the top of our page, and then you have your view. And if someone would click on a button in one side of our views, it's like a kid. Like, what's that? Your view should not be doing any logic. It says, what's that? And it fires off an event, which bubbles up to the store, to your Redux layer. And then it's the responsibility of the smart parent to do some calculations, make some API calls, get new data, and return a new object, which then goes back down to the view, and the view updates based on whatever that object shows. And if you're interested in using Redux with Polymer, like if I've convinced you to use the Polymer library, there's a great talk by Rob Dotson on how to do that. But again, this is great because it decouples your state from your UI. And the reason why you want to do this is my colleague. He says, I've been married and divorced to so many front-end frameworks that I want to stay a bachelor for the rest of my life. I'll just let that sink in for a second. I really love that quote. Rich Hickey would say it another way. He would say, can you move it? You know, this is kind of like the concept of decoupling. Can you take your business logic and state store and move it out of React, move it out of Angular, move it out of whatever framework you're having, and have it as its own little GitHub repo? We do. And we need to do that because we actually have a website. We have this in native. We have this as our X1, so you can actually view our website on the X1 TV. And the UI is completely different for it, but it uses the same state store. It uses the same Redux layer. And it's also much easier to test JavaScript than it is to test UI. You can write all kinds of functions to test your state store that you don't have to test your UI because your UI is just displaying based off of an object. If you're interested in building an end-to-end app, there was a great talk by Kevin at the Polymer Summit where he built an app in like a week for real estate listings. Check out that talk. I'm going to tweet out the slides too at the end so you can get all the links from here. And the great part about when you break things down is it's really easy to develop new features. The teams at Comcast can be quite large. The XFi team has, I don't even know how many people now. It's like over 40 front-end developers. But if you get a new feature, let's say we have to build this new page, you can have one developer do the state store and just update that. You can have one developer whose responsibility is building the whole page. And then he can break it down into someone else builds this recent activity component. And then someone else can build this access rules. And I think you get the idea. But the great part is for engineers, it really gives you the ability to focus on the tasks that you have at hand. Another thing that we like to practice, how many people have heard of TDD? Yeah, everybody. How many people have heard of DDD? This is my colleague termed this. What is DDD? It stands for Demo-Driven Development. Yeah, like what does that mean, right? Like the cool part about building web components is each one of these exists in its own folder. So you can actually build SI page owner entity, and it can render in its own HTML. You can put that on the page. You can give it mock objects and see it display and work correctly. And it works completely separately from the rest of the app. And that thing exists by itself. All of the tests are in the folder for it. It runs. It starts up. The other cool part about Polymer is there's no pre-compiler that has to happen. Everything just runs in the browser. So you don't need like JSX where you have some kind of process running which converts it to something else. Everything that we have here is running directly in the browser. There's no pre-compilation step. There is a build process to go to production so that it concatenates and bring everything together. But that's it. The other thing that Rob mentioned, which is one of the cool things that a lot of frameworks are trying to figure out, is how do we share components? Sharing components is really, really tough. It does not come naturally. People do not like to share things. They like to play keep away. But if you do want to share components, you need a team. You need a team that owns those components, builds those components, manages those components, does all the bugs and features. You need people dedicated to it. You can't just have teams random sharing stuff because it just doesn't work. It's really hard to do it, even with web components. If you want to download and use web components that exist, there are a ton of them out there. There's webcomponents.org. My favorite one is there's like a QR code scanner. So you actually just download a component, put QR code in your HTML markup, and now you have a QR code scanner which returns like what the QR code reads. Really great. So in summary, hopefully I still have everyone's attention. I think so. Cool. Decouple all the things. You want to make things simpler. You want to break things down into the smallest pieces, smallest components that exist. But simplicity, and the reason why you want to do this is because simplicity matters. But simple does not mean easy. A lot of things in life are really hard. Some of the stuff that I've done at Comcast have taken over a year or 6 months of just like constantly focus on it, getting reviews, getting people to do it. But it has tremendous benefits once you do it. Again, it's really hard to do it, but once you accomplish it, you get to move so much faster. So take on the challenges that you have, because if you break things down, you make things better. Simplicity creates opportunity. You're going to be able to build things so much faster than everybody else. If you like this talk, you want to know more about Polymer, I have a bunch of other talks that you can actually check out. This, again, will be in the slides. I go into more depth about what Google Polymer is. And thank you. We're good for questions now. Yeah?
I wanted to ask you, I mean, I'm not familiar with how old Polymer is, but how do you think it aged? Like in terms of maybe today, it's very nice because it's used as a platform. I guess it will integrate easier with the other existing frameworks. But in terms of as time passes by, or as time has passed by, how is it aging in terms of still being very compatible with existing platforms and being compatible with other frameworks?
That is a great question. So basically, how good is Polymer today? I'll summarize that as that, right? Like, and should you use it? So that's another great question, which I will love to answer. I think the benefit of the Google Polymer project is they introduced these web component specs. And now what we see today is Angular, Vue, React, like every one of the frameworks that you're using will take advantage of custom elements. They're also taking advantage of exporting as just a custom element, because they really want to get to this point where you write it in any framework, and then you can take that component, drop it in any other framework. You can really share stuff. The Google Polymer library has gone through a lot of changes over the last couple years, especially as like the V0 spec for web components and the V1 spec, which got adopted, came out. They just released Polymer 3. They dropped HTML imports. They're using ES6 modules. It is very difficult to build a website with Polymer. I recommend that you use a framework that has a bunch of nice stuff in it. As Rob pointed out, he had that one slide of like the 20 different things that you really need to build a full stack application. That's why frameworks are great. Use a framework. Polymer is fun. They have a lot of those components. And I think Polymer has also gotten simpler over time because they're following a lot of the standards now that React has of like using import, module, definition. So it has gotten a lot better. And I do really like it. There's still a lot of complexity involving Shadow DOM. So Shadow DOM is something that takes a lot of time to get your head around. Because once you encapsulate something, it's like, how do I style this thing? How do I theme it? And there are new specs that are coming out of it. So to summarize, I'm going to summarize now. Polymer created great opportunity with custom elements and web components, which created new problems that new stuff is now coming out to solve. But everything's getting better. And once IE 11 is gone and all the browsers are auto-updating, the world will be a great place. Thanks. More questions? Yeah.
Two questions. From a Comcast perspective, are you going to migrate to Polymer 3?
That is a good question. So a bunch of our sites are written with Polymer 1. So even going from Polymer 1 to Polymer 2 is difficult. There's like a lot of code behind it. We are actually considering switching off of Polymer. So flat out. The reason for that is because web components are great. They solve certain use cases, but they actually also introduce a lot of complexity too. If you have to support IE 11, Polymer is very difficult because you have to transpile everything, and you have like an ES5 version for IE11, and you have a different version for modern browsers. And it's like annoys me so much when, why go through all that complexity if you can have something like Preact, which is really small, doesn't necessarily need web components, still provides encapsulation through CSS and JavaScript, use something like that. So we are also considering Vue.js too. Vue.js is another great framework.
So in Comics, you port the components over, or you just completely?
Yes. So if you add in Polymer 2, the Polymer team has created a command line tool that will actually parse through all your thing and switch it to the new syntax. So yeah, they do have a tool to do that and convert your components from one to the other. More questions? I know there's more great questions. Okay. Thank you.